Welcome to today's Explainer. So we're diving straight into a completely fascinating and honestly kind of maddening economic mystery that is currently sitting on the desk of every major technology executive right now. We're looking at the great AI cost paradox of 2026. If you've been tracking enterprise AI adoption, you know the numbers have been dizzying. But the financial reality? It's telling a story that feels completely backwards. How on earth are we spending more while supposedly paying less? Well, let's get into it.
90%. Think about that for a second. Between 2023 and 2026, benchmark unit token prices, the fundamental raw material powering all these large language models, they've absolutely collapsed, down by roughly 90 to 98%. Now, if you're a CFO or an engineering lead looking at that trend, your logical expectation is pretty straightforward, right? Delivering AI-assisted software should be getting progressively ridiculously cheap. I mean, if your primary raw material costs 90% less, your bills should shrink. It just makes sense.
But here is the mind-bending twist. Juxtaposed against those plunging token prices, we've actually seen overall enterprise generative AI spending just explode. I'm talking a staggering 22-fold increase. We went from an estimated $1.7 billion in 2023 all the way up to $37 billion in 2025. Aggregate token expenditure is roughly doubling, even as the unit prices fall right off a cliff. What we're looking at here is the textbook signature of an efficiency-driven demand explosion.
And that brings us to the core contradiction. According to the 2025 Google DORA report, AI adoption has hit 90% among software professionals. They're using it for a median of 2 hours a day, and over 80% are reporting genuine, measurable productivity gains. But here's the catch. Total software delivery costs are climbing sharply, and engineering headcounts haven't really shrunk at all. What happens is, the product roadmap just expands to absorb all that new capacity. You're attempting way more epics, sure, but your total bill is quietly surging behind the scenes.
And this creates a massive, hidden, downstream mess. Look at the 2026 telemetry data from Pharos AI, which tracked over 22,000 developers. They found that AI helps teams complete 66% more epics, which sounds amazing. But wait for it. That speed triggers a massive 441% increase in median pull request review time. They literally call it acceleration whiplash. It's the ultimate hurry up and wait scenario. Writing code faster just creates these huge, incredibly expensive bottlenecks in security and architectural reviews. Those are costs that never show up on your AI vendor's invoice, but they absolutely burn right through your engineering budget.
Let's anchor this in some real-world 2026 case studies, just to see how out of control this can actually get. Take Uber. They saw their per-engineer monthly API costs for AI coding tools just skyrocket, hitting between $500 and $2,000. They exhausted their entire annual budget by April. Or Microsoft, who literally had to order a division to stop using certain tools right before their fiscal year end because they hit a $2,000 per engineer run rate. Even GitHub Copilot ended up transitioning some of their heavy users to metered billing, resulting in monthly bills of up to $3,000. So that expected $10 or $20 flat sticker price? Yeah, for complex users, it's basically a total myth.
To actually understand why cheaper efficiency leads to this vastly expanded total consumption, we need to travel back in time a bit. It turns out we have to look at an underlying economic theory from the 19th century, because it's exactly what's dictating the reality of 21st century compute. Enter the structural Jevons paradox. Back in 1865, William Stanley Jevons noticed something super counterintuitive. Making steam engines more efficient didn't actually reduce coal consumption, it increased it, because suddenly coal power became economical for totally new, expanded uses. Today we're seeing the exact same thing. Falling AI unit prices don't cause firms to save money on their existing workloads. Instead, it causes them to completely redesign their workflows to consume dramatically more compute per task. They start using deeper reasoning chains, complex multi-agent pipelines, you name it.
And this isn't just some academic theory either. Top tech leaders are openly acknowledging this dynamic right now in 2025 and 2026. Industry giants have explicitly pointed out that as the cost of a given AI capability falls, the usage expands much faster than the price drops. Basically, every single efficiency gain at the foundational infrastructure layer gets instantly swallowed up and reinvested into vastly larger application consumption.
Think about how this consumption actually multiplies in practice. A single, simple chatbot query. That's cheap, it's predictable. But when you move to a multi-step agentic workflow,
where, say, an autonomous AI agent is tasked with fixing a bug, using tool calls, verification loops, and massive context windows, it suddenly consumes 5 to 30 times more tokens per user action, and sometimes for complex automation, it's 100 to 1,000 times more. The architecture literally redesigns itself to spend your savings.
So what does this all mean for your broader financial picture? Well, that API token sticker price everyone is obsessing over, it's really just the tip of the total cost of ownership iceberg. If we want to see where the real enterprise money is actively burning, we have to look below the waterline. When you break down a defensible AI total cost of ownership model, you get a pretty sobering reality check. It turns out data readiness, preparation, and integration engineering make up a massive 40 to 60% of total build costs. And it doesn't stop there. Ongoing monitoring, drift detection, and retraining, that adds another 15 to 25% of the build cost annually, in perpetuity. So the token API cost that CFOs are staring at is really just a deeply misleading sliver of the actual financial burden. And then we have the ultimate hidden tax, 5%. According to massive 2026 optimization studies looking at tens of thousands of enterprise Kubernetes clusters, 5% is the median GPU utilization rate, 5%. Organizations are provisioning and paying for peak capacity and then just letting it sit completely idle most of the time. This massive, hidden inefficiency artificially inflates the effective cost of every single token you process. It's wild.
So, with all these ballooning investments, these runaway agentic workflows, and all these hidden costs, we really have to ask a blunt question. Across the different departments of a typical enterprise, where is this technology actually paying off? Who is making money here?
Customer service is actually where we see the most mature, auditable cost data. To put it into perspective, a human-handled interaction costs roughly $12, while a comparable AI-resolved interaction costs around $2. That is a massive, clear unit cost advantage. And it generates a blended industry return of roughly $3.50 for every single dollar invested. So in this specific back-office function, the math firmly absolutely works.
But step outside of those proven operational silos, and you hit what we call the enterprise gap. And it's a harsh reality to digest. 95% of enterprise pilots produce zero measurable profit and loss impact. 80% report no EBIT impact. Why? Well, over half of generative AI budgets are being misallocated to highly visible, flashy sales and marketing tools, rather than the unglamorous back-office operations where the actual math works. Worse still, moving a successful pilot into production routinely costs 3 to 6 times more than anyone planned for. So how exactly do technology leaders survive this? How do you manage a technology that somehow gets more expensive the cheaper it becomes? You need a clear economic framework and an actionable survival guide. Welcome to the new FinOps playbook.
The absolute first step here is a critical mindset shift. You have to stop tracking the useless cost per token metric. The API cost is reliably falling while your true consumption is rising, so it's a terrible gauge. Instead, your new KPI must be cost per outcome, meaning the fully loaded cost per resolved customer ticket, or per safely merged pull request, or per shipped feature. Boards and CFOs fund outcomes, right? Not outputs.
And getting there requires a really strict set of ROI gates. First, you pick a specific outcome metric. Second, you capture a pre-deployment baseline. Third, you count the fully loaded total cost of ownership. Fourth, you actively redesign the workflow. And finally, you make a hard scale or stop decision. The data is super clear on this. Organizations that strictly document their pre-deployment baselines before spending a single dime are over 4 times more likely to demonstrate actual, real-world returns.
On the engineering side, you need to deploy some fairly unglamorous but absolutely essential mechanics. You've got to implement session-level attribution tagging so you know exactly which workflows are eating your budget. You need prompt caching, and you definitely need continuous batching to fix that dismal 5% GPU utilization we talked about earlier. Plus, dynamic routing to send simple tasks to cheaper models. These are the specific, on-the-ground tactics that actively manage that Jevons dynamic and keep your costs tightly bound to actual business value. Which brings us to a final, provocative question you should probably be asking your teams tomorrow morning. Are you funding AI outcomes, or are you just buying cheaper outputs? Because if you aren't actively redesigning your workflows and aggressively managing those hidden costs, well, those plunging token prices are really just going to buy you a vastly bigger bill.
Thank you so much for joining me on this explainer. I really hope this helps you critically reevaluate your own AI strategies, and I'll catch you in the next one.